Sample problem 2.5 deals with calculating the atomic mass of an element. And like I said in the sample problem 2.4, the mass number is usually close to the atomic mass. Or in other words, the mass number of the most abundant isotope is usually close to the atomic mass. And the atomic mass is the actual number you find on the periodic table. And the unit for that they use is atomic mass units, this AMU that you see in this table here. So the example says we have silver, Z equals 47, has two naturally occurring isotopes, silver 107 and silver 109. From the mass spectroscopic data provided, calculate the atomic mass of silver. And this is how all of the atomic masses on the periodic table were calculated. They used these spectroscopic methods to determine this. And so the data you get from an experiment like this is the actual mass of, so the mass of silver 107 is shown as 106.90509, and then it also gives you an abundance, or a percent. So this 51.84 means that 51.84% of all the silver that we have here on Earth is silver 107. 48.16% is silver 109. And the actual atomic mass unit for silver 109 is 108.90476. So how we determine the actual molar mass that goes on the periodic table is we do a weighted average of these two and add those numbers together. So let me explain to you how to do that. The first step is to convert the abundance percent into the fractional percent. And so anytime we have a percent, such as 51.84%, if we divide any percent by 100, we get that number as a fraction. So that's going to be equal to 0.5184. Do the same thing for the 48.16 divided by 100 is going to equal 0.4816. Now that we know that fractional number, we just simply multiply the mass of each of those isotopes by their fractional number and then add those two numbers together. So for silver 107, I'll put silver 107. Alright, we have 106.90509 times 0.5184, and that is going to equal 55.42, and the unit here is AMU, this atomic mass units. We do the same thing for silver 109, so I've got AG 109. I have 108.90476 times 0.4816, so that's going to equal, if I type that in the calculator, I get 52.45 atomic mass units. And now to find the atomic mass, and I'll write it like this, atomic mass of silver, we just add those two numbers together. And that's going to equal, so 55.42 AMU plus 52.45 AMU equals, and I got 107.87 AM.